Hello children, welcome to EINSTEIN'S Physics. Today we are here to discuss the topic Einstein's photoelectric equation. That was done in the year 1905 and for which he received Nobel Prize. Now, this equation was formed under the basis of Max Planck's quantum theory. He used Max Planck's quantum theory to form the equation in this manner. Okay, now let us see what is Max Planck's quantum theory and how he could reset this equation. Now, what is Max Planck's quantum theory? According to the quantum theory, light is transferred in packets of energy. That packets was named as quanta or photon. He used the name quanta or photon to address the packets of energy. The packet was named as quanta or photon, and each quanta or each packet has an energy equal to h nu, where h is Planck's constant, the value 6.6 to the power 10 to the power minus 34 joule second. So that was Max Planck's quantum theory. Now, what Einstein sir said that when a photon is incident on the metal surface, the energy is distributed in two different ways. Energy was distributed in two different manner. What are the things he used? Number one, some amount of energy is taken to remove the electron from the metal surface. And the second one, to impart kinetic energy for the electron. For example, if you think like you are taking a tooth out of its mouth and then throwing it away. Just for imagination, you can think like that. You need some kind of energy, pushing and pulling, you are taking the tooth out. And that tooth you are taking out, that means you are removing the electron from the metal surface, and once it is taken out, throw away. So that is the second part. Throw away means to impart kinetic energy so that it moves away from the metal surface. So that's a simple example to memorize photoelectric effect. So what is photoelectric effect? Taking the tooth in a manner that you are removing it from that socket. Then the remaining part you are imparting kinetic energy so you can throw it off. So the two purpose. And the first part is known as phi 0 or work function. Phi 0 or phi naught work function, the minimum energy required to remove the electron from the metal surface. Whatever that energy needed, you give it for phi 0. The whole thing, the remaining whatever be the value, that can be given to kinetic energy. So it's a maximum value, possible value you can get for kinetic energy, because this has a fixed value that you have to give here. Only the remaining you can take for K max, and for each and every metal this varies. Therefore, phi 0 or phi naught is a value which varies with metal, and that particular value has to be reduced from h nu. That will be K max. So that is the final equation. K max is equal to h nu minus phi naught. H nu in the sense the incident photon, phi naught work function. So the difference of the two has the value K max, or K max is the kinetic energy of the ejected electron. That will be always the difference of incident energy and the work function. So this is Einstein's Nobel Prize winning equation. Okay. Now this is rewritten in this manner. Phi 0 is given as h nu 0, where nu 0 is a term known as threshold frequency. We have discussed in the earlier videos. Threshold frequency will come back again, and kinetic energy maximum is half mv square maximum. Now substitute here what you will get. Kinetic energy maximum is half mv square maximum, h nu minus h nu 0. So this is what you will get. And one more thing you know, half mv square maximum is EV0. What is V0? V0 is stopping potential and E times V0 is known as half mv square or kinetic energy maximum. We have studied this earlier. Stopping potential means what? The energy to stop the incoming electrons. So the incoming electrons are coming with a kinetic energy. So you are giving such a potential so that it is stopped. So whatever be the incoming energy, the same you has to give in the reverse manner to make it stop. That's why both are same. Now from this equation again V0 equal to h by E nu minus h by E nu 0. So this is of the form straight line y equal to mx plus c with the slope m as h by E. And that again we will come, we already have drawn graph where V0 and nu are straight line or it is having directly proportional relation. Okay. Now what are the observations we get finally from the equation? So this equation gives us lot many informations, or these are the observations what we summarize. Number 1, K max depends on frequency. Explicitly clear from this equation? Because you know this is the equation, same thing. H is a constant, have a value. So if you remove the H, it becomes directly proportional. Means when K max come up, frequency come up. K max come down, frequency come down. So they have linear dependence. The one is proportional to other. But nothing in this term, you don't have anywhere a term like intensity. So it is independent of intensity. K max has nothing to do with intensity of the incident photon. Now second thing, a single photon can eject a single electron. 1-to-1 ratio. One photon, one electron. That is the case. Next one, K max must be non-negative. This is a very surprising word, non-negative. That was used in a very particular specific manner to say it is non-negative. Otherwise you could have said positive value. But non-negative because you look at this equation. If this is 5 minus 3, it is positive, right? But if it is 3 minus 5, it is negative. Meaning what? 3 is nu, 5 is nu 0. So you can't have an incident photon with 3 energy, whatever be the units, and you can have a work function 5. Why? That defines the term threshold frequency. So there is a limit set. The set limit is known as threshold frequency. You can't have a photon whose frequency is lower than threshold frequency. If it happens, no emission. So it's well clearly explained, nu should be always greater than nu 0. You can't have never a value 3 and 5. Always it should be greater than nu 0. Nu has a value which should be always greater than nu 0. So there exists nu 0. There is definitely a term. The two important new words are, one is work function, the other is threshold frequency. There is a limit, there is a cutoff. Only above that you have photoelectric emission, or the reverse. Below threshold frequency, no emission is possible. Whatever be the intensity, whatever be the time falling, no problem, there won't be emission. Suppose you are making the intense beam to fall a long time, or you are using a high intense beam. Even then, no emission will be possible until and unless this rule is kept. What is this rule? The incident photon should have a frequency above nu 0. Very, very important word, threshold frequency. Other one, greater than nu, greater the kinetic energy maximum. That already here it is mentioned. Here Ke depends on nu, directly proportional. And this again shows I proportional to I. What is I proportional to I? Intensity proportional to photoelectric current. Why? Higher the intensity, what will happen? Higher the number of photoelectrons coming out. Photons are falling, if more number of photons are falling, I told you a single photon ejects single electron. If more photons are falling, what happens? More electrons are coming out. So what happens? Greater the incident frequency, greater the K max. That means I proportional to I, intensity proportional to photoelectric current. This process is instantaneous, no time lag. As soon as photon is coming and falling, electrons are getting ejected. So no time lag. Now finally this equation I told you, V0 versus V curve is a straight line with the slope h by e. And Millikan was a scientist to measure this h by e slope. He did the experiment with lot many materials. And finally he could understand h by e equal to m. So from that h is equal to m into e. With that equation he could exactly stamp. He started it for disapproving the equation, but finally in 1960 he has to prove that Einstein was perfectly correct. So actually this confirmatory test for Einstein's photoelectric equation was done by Millikan sir, and in the year 1916 he proved instead of disapproving. He started with disapproving tendency, but finally he has to prove that it was perfectly correct because the value of h obtained was perfectly okay. So thank you for listening. If you have any doubts regarding, please put in the comment box. Thank you.